Okay, hello, and this is our last class meeting, except the mini lab makeup. That's I'm not sure if I see you again, but let's do a quick review of the concept of the third exam and see if we have any questions. So the first topic is op amps or operational amplifiers. Now, remember, you have three important rules to remember for op amp analysis. The first two, you should apply them to your circuit. The current rule and the voltage rule. The current entering the op amps, whether through the negative terminal or positive terminal, should be both zero. And about the voltages, the voltage at the inverting terminal or negative terminal and the positive terminal or the non-inverting terminal should be always equal. And the third rule that is, well, you don't apply it, but you should be very careful, okay? So the output current of an op amp is not always zero, okay? It's not necessarily zero. It can be non-zero. Always remember that. Also remember the properties of ideal op amps. The input resistance is infinite, the output resistance is zero, and remember to, if you had any conceptual questions, to apply these. Now, I've brought all the circuits in op amp that you had, the famous circuits, but remember, if you have a circuit that is not among these, it doesn't mean that you can't answer the question. Just apply the rules and analyze the circuit, exactly as you would do for any other circuit. One thing that I would suggest, if you have some spare time before the exam, it would benefit you if you can memorize these structures and their corresponding formula. For example, if you see something like this, you don't have to analyze it once again. You can directly write the equation for gain. If you are confident enough that everything else is good, you have covered everything that you need, and you just have some extra time, then you can do this. But be very careful. If you confuse them, then you might get it wrong, okay? For example, what helps you in memorizing this equation is that the input signal should be given to the positive terminal to make it non-inverting amplifier, okay? For this one, the input signal is given to the negative terminal. That's why we call it inverting amplifier. So if you memorize this, it will help. Either more than two signals are given to the negative terminal, they'll be combined. The positive terminal is grounded. You have a feedback resistor, RF. This is how you can just get close to memorizing them. This is differencing amplifier. One is given to positive terminal, one is given to negative terminal, and the output provides the difference of them, okay? And also, of course, the differentiating and integrating amplifier. But remember, even if you don't memorize them, it doesn't mean that you're gonna miss that question, because you can still answer that question by analyzing the circuit, okay? The complex numbers and sinusoidal signal, these are the part that you don't have to memorize. Just one thing. First of all, remember to set the mode on your calculator to whatever that you want, okay? Be aware of that, whether it is degrees or radians, okay? Don't combine them. Also, whenever you're doing inverse tangent, remember to check the quadrant of the answer. By default, the answer given to you by the calculator is in the fourth quadrant if the tangent is negative. But sometimes you have to move the angle from fourth quadrant to second quadrant, okay? And how do you do that? Add pi or add 180 or negative 180 to the angle, and it will give you the equivalent angle in the second quadrant. One example that the students usually struggle is something like this. If you have cosine omega t plus theta, for example, okay? What is omega usually, what is the units of omega? Radian per second. theta is usually given to you, or you derive it in degrees, right? So if you plug in theta in degree and omega in radian per second, it's messed up. You guess why? Because radian per second, when multiplied by t, which is second, will give you radian. You cannot add radian to degrees, okay? So it's better to change theta from degree to radian to make everything consistent. Am I making sense to everyone? Okay? This is a plot of a sinusoidal function. Remember that whatever is multiplied by sine or cosine is amplitude, okay? Whatever is alone in the equation, this guy, it's the DC value, okay? It's not multiplied by anything. It's not time dependent. Whatever is multiplied by t is called radian frequency, and this guy alone is the initial phase. Now, definitely you're going to get something about lead and lag, okay? So you have to compare two signals. How can you compare two signals in terms of lead and lag? Both of them or all of them must be in cosine form. All of them must be in positive form, not negative cosine, positive cosine. And all of them must definitely have the same frequency. And you're not going to get different frequencies because that's beyond the scope of this course, okay? So remember, same frequency, positive cosine, and that's it. Now, in order to understand the lead and lag, I want you to remember this. In which direction do phasors move? Counterclockwise, right? Counterclockwise. Now, whoever is chasing the other one is lagging, right? And whoever is being chased is leading. For example, in this scenario, if V1 is chasing I1, then we can say V1 is lagging I1. By how much? 153 degrees, right? But if you want to talk about I1 chasing V1, remember the direction of movement. The direction of movement is in that direction, right? So if I want to say that I1 is chasing V1, I have to say I1 is lagging V1 by 207 degrees. Okay? Does that make sense to everyone? So for every plot that you have, you can write 4 valid statements. Okay? Which ones do we prefer? No. There's no preference between lead and lag. A smaller angle is preferred. Okay? That's why I've shown that check mark besides 153 degrees. A very important yet probably very simple is to change a cosine function into phasor. Okay? So the first thing that you have to check is it should be positive cosine, okay? If you want to write its phasor, positive cosine. So how do you write the phasor? Just the amplitude and then the phase. If it is positive cosine, and it will give you your phasor. Now, about different components. We have for resistor, we have in phase. What does it mean? It means that the voltage and current go together to 0 positive peak, 0 negative peak, and so on and so forth. For inductor, what is the impedance of an inductor? What is the impedance of an inductor? J omega. What is an impedance of a capacitor? Negative J over omega C. What is the impedance of a resistor? R. And what is the imaginary part of impedance called? Reactance. What is the imaginary part of complex power called? Reactive power. See, they are very similar terms. Reactive power and reactance, okay? Remember, in inductors, current, first bring current lags voltage by 90 degrees, okay? Current lags voltage by 90 degrees. So I can say voltage leads current by 90 degrees. They are the same thing, right? Current lags voltage or voltage leads current. They are the same statement. For capacitor, current leads voltage by 90 degrees. Just one question. If it is not inductive, but it is, if it is not inductor, but it is an inductive load, what can you say about, how can you finish this sentence? I lags V by? By an angle between 0 and 90 degrees, okay? Okay. Remember this plot, this is the position for resistor, inductor, and capacitor, okay? Now, can you tell me why only the right half plane is highlighted, not left half plane? So, does it mean that I can't have any impedance which is located on the left half plane? Why not?
Resistance is always positive.
Resistors are always positive values, right? So you can't have anything on the left half plane. And power terms. You have many power terms. All of the equations are given to you except these two. This one and this one. The first one is the fundamental definition of average value for any function. It doesn't matter what function it is. P average is 1 over t, integral from 0 to t of the instantaneous power. Now, in a couple of exam questions, instead of giving you the power, the PT, the question has given you VT, which is the voltage, or they can give you current, okay? So is there any way to calculate average power? So just compare these two equations together. See? What should be inside the integral? PT, instantaneous power, right? Can I write, instead of PT, can I write V squared T, VT squared over R? Okay, so remember, if the value of R is given to you and the voltage, or if the value of R is given to you and the current, what should be inside the integral? R IT squared, okay? So they are exactly the same thing. Remember, all these equations are given to you based on whether you want to use voltage or current. The effective value, okay? A couple of important things. First of all is recognizing what the period is in your problem. So you can replace it with T here, substitute T with. The second one is sometimes you forget. It should be a squared version of the voltage or signal, whatever that is, okay? The third important thing to remember is do not use the area, okay? You can't. Why? Because that signal is squared that should be integrated, not the signal itself. So don't go for the area. And one more thing is, I have seen a student that whenever a signal is given to them to find the, find the RMS or effective value, they just divide some number that they find about that function, they divide it by √2. What's wrong with this? They divide the number, for example, the height of the function, they divide it by √2. What's wrong with that method? The amplitude divided by root 2, is it applicable to all functions or no? Only for sinusoidal function, okay? The effective value of a sinusoidal function is amplitude divided by root 2. For any other signal, what should you do? This formula. Directly, you should calculate it, okay? That's very, very important. Now, is this a sinusoidal function? No, it's not. It's not a sinusoidal function. Why? Because it's not. It's a screaming. Do you see some period of time, some interval, it is completely zero? So it's not a sinusoidal function. This is sinusoidal, right? It's not. Okay, so how do you calculate its RMS value? Okay, let me ask you this first. What is the period of this signal? That's one of the common mistakes, almost half and half. Is it 3 or no? Why not? Because does it complete a cycle in 3 seconds? No, in 5 seconds. That's very important. 5 is the period. The second problem is when you plug into this equation, what should I plug into t? 5. How about this t? 3. Why? Because the signal is 0 from 3 to 5, so you shouldn't integrate something that doesn't exist. Am I clear on that? See? So the first one is 5 because that's the period of the function. But in fact, just let me tell you this to make it less confusing. If you want to write it correctly, you should write it like that. Make sense now? Okay? So the part from 3 to 5 is just neglected. Yeah, if it is another function, you should include that instead of 0, right? Yeah, exactly. Again, complex power. I need you to all remember that. Complex power has 2 representations like any other complex number. One is polar. Which information you can get from polar representation of the complex power? What information can you get from polar representation of the complex power? Apparent power? Angle. Power angle. What information can you get from rectangular representation of the complex power? Average power and reactive power, P and Q. Okay? What are the parameters that have the units of volt amps? Complex power, apparent power. So if a number is given to you in volt amps, how can you tell if it is complex power or apparent power? There's no mention of that. Just a number is given to you. 10 kilovolt amps. Which one is it? Why is it apparent? Because it doesn't have any angle or imaginary part. So it's a real number, so it's definitely apparent power. If it is given to you by some angle, then it's complex power. Okay. So if a voltage is given to you in the statement of the problem, there is no mention of VRMS in it. What should you consider it? For example, the voltage connected to the network is 200 volts. Should you consider it RMS or no? No. What do you consider it? Amplitude. Okay? Amplitude. If you want to change it to RMS, what should you do? Divide it by a square root. Why are you allowed to divide it by a square root? Because it's a sinusoidal steady state analysis. Okay? Okay, this triangle helps a lot. okay? I mean it. And it's not difficult. Just P, Q, apparent power, and the angle. Then if you remember the definition of sine and cosine and tangent, it will help a lot in many problems. These alternative relationships are also very useful. For which cases? For when you have access to the impedance. Now this is my question. When can't you use these equations? Give me a component, for example. Any type of source, you cannot apply this to, right? Because do you have the impedance of a source? No. Okay, so you have to go to which equation?
For a source?
Either of these two, the most general equations for complex power. Either of these two equations work. And you need to have both voltage and current. But these equations are useful in the sense that you only need one of them. You only need either voltage or current. Okay? One important thing about this, I mentioned it in class. Remember that the one working with voltage has Z conjugate, but the one working with current has just Z. Okay? Remember, inductors absorb reactive power and capacitors supply reactive power. Okay? Power factor correction, just these equations, which are the fundamental ones, I've already written this one as well. Because sometimes they give you, like the last example that we did in class, if I remember correctly, the P was given to you and the power factor, and you needed to find apparent power. So just a little manipulation to the original equation give you the extra equation. You don't have to memorize it. I just want you to see how it works. These are different cases. Remember, whenever you see lagging, it means inductive. Whenever you see leading, it means capacitive. This is the equation for capacitor that is required to compensate or do a power factor correction. The only thing that you need to remember is that whenever you want to find the angle based on power factor, if the power factor is lagging, we add positive. If it is leading, we should use the negative sign. Okay? The equation that I talked about, the average power, I wrote them here so you remember these are important, okay? Okay, let me see. Yeah, this is for the questions where voltage is given to you with one resistor, and you can apply it to that. It doesn't mean that you can't apply it here. Let me write it, okay? So it's actually, I believe it's easier. It's easier to use the original one, but you have to remember. If the voltage is given to you, how do you find current? It's divided by resistor, Ohm's law, okay? Then just multiply Vm and Im and cosine theta V minus theta. This purple one is easier, but I want you to have the red one as well. These are some questions from the previous years or quarters that I just did. This is one of the questions that was actually, there's a lot of mistakes in it. So let me do it again to see. Okay, so I'm gonna start reading the choices and you tell me if these are correct or no. First, the voltage drop across the network. Here is the network. It's a resistor and capacitor connected in series, okay? So, the voltage drop across the network and current flowing through the network are in phase. Is that correct or no? Why not? In phase is only for pure resistor, okay? So that is incorrect. The network will operate at the leading power factor. Is it false or correct? Why is it false?
Capacitors are so have a negative.
So it says leading. So is it correct or no? Correct. Third, the angle of the impedance will be positive. False. Right?
Would the impedance be a negative angle, which would then just be capacitive?
Yeah. And next, the network will be absorbing average power. Is this part correct?
Yes.
Why?
Is this the
There's a resistor. Resistor always absorb average power. And supplying reactive power. Yeah, because there's a capacitor. This is correct too. The voltage drop across the network will lag the current flowing through the network. Yes or no? Why? It's a capacitor. In capacitor, current leads voltage, so voltage lags current, right? The average power absorbed by the network must be 0. Definitely not, because there is some resistor. So you see that the question is wrong. Okay, questions? Nothing? Okay, there are some examples that I did here, and you can refer to them. Okay, see you at 6. And yes.
Can we do an example of a type of Weber problem and one of works?
So what do you mean example?
Like,
Do you have anything in mind? Okay.
if V
Is it exam material or is not?
could probably gonna be honest.
Okay, is it if it is too complicated or if it is
It's easy and simple.
okay? Can you tell me which problem is it?
I think it's homework 23, problem 2. It has you adding phasors, but with different periods.
23
Yes, sir.
problem.
Problem 2.
That's not exam material. No. If you want, this is just for general knowledge. You said different frequencies.
That's not the one I was thinking of. It's in 23.
Okay.
No. Is it home? Oh yeah, it's that one. The last two, it has you adding.
No, that's not exam. But if you're interested, I can help you how to do it. What is it asking?
The bottom two, it has you adding.
Okay.
First time 200T and then.
You see, do you know the equation for? Okay, let me ask you a question and then you can go. Let me ask you a very. I believe it's a good analogy. So, there are two buses on campus, okay? They go around the campus. One takes 5 minutes to go around and come back. One takes 4 minutes. Okay? So do you agree that 5 minutes is the period of the first bus and 4 minutes is the period of the second bus? Okay. How long should I wait for the two buses to arrive together?
Together,
20 minutes?
20 minutes. How did you get that? What is it? I always call that LSD and everybody laughs. What is that?
Lowest common multiple?
LCM? LCM. Okay? So let me ask you this. If you have two periodic function, one of them has the period of T1 and the other one has the period of T2. What is the common period if you consider them together or some of them? No, not T1, T2. What was it? LCM of T1 and T2, okay? Not necessarily the multiple, okay? Sometimes it's different. For example, 5 and 15 is 15, right? 5 and 10 is not 50, it's 20. See, LCM is different than multiple. Okay, so what about this question? Do you remember the formula for effective value? A square root 1 over t integral from 0 to t of the signal. So you have the signal. The only thing that you should be careful is that the t is not the period of the first cosine or the second cosine, is the period of the whole signal together. Did that make sense? Okay, so it's just a tedious work on functions. It's not a
yeah, you're
like.
not meant to write it out as.
No.
Same thing.
Yeah.
Okay.
Yes.
When you're finding equivalent impedance, and you have like, you're given that these are capacitors and inductors and stuff,
Okay.
do you add the capacitors like you did when we did resistance or whatever, or capacitance, where it was opposite of resistors, or like a capacitor in parallel, you add the, would you add the, resistors?
No.
Or do you just do
No.
it like they're all resistors?
They are all resistors because in phasor form they are all impedance actually. We don't have any capacitor anymore. And what is the units of impedance?
Ohms.
Then treat it like resistor.
Okay.
Even if it is capacitor. That's a good question. Yeah. Question?
I have a problem.
Yes. Yeah.
You do this one.
Do you know?
That's the 2024 exam. It's the last question.
You just take a question like that off the exam, right?
Okay. The voltage present at the output terminal of the op-amp circuit shown below is closest to. Okay, let me see. So these two current are 0. Let me see if I so touch. Okay, so since I positive is 0, can you tell me what is the voltage drop across this guy?
Why is I positive?
It's always 0. The current going into the op amp is 0, right?
Like 6.15 volts.
Did you multiply it? What was it? 6 point?
6.15.
6.15 volts. Okay? Now, the negative terminal is connected to 12.8, right? So what is the positive terminal? You should add it together, which is 18.95. So here is 18.95 volts, right? Did I anything wrong so far? Now, since that point is 18.95, this point is also 18.95, right? Now write a KCL at this point. So what can I write? I can write 18.95 minus 14.7 divided by 6 plus 18.95 minus V out divided by 10.4 minus 3.4 milliamps is equal to 0. One equation, one unknown.
What did we just do the KCL for?
KCL at here.
Okay. The negative part of the thing.
Sorry?
The negative terminal of the whatever that triangle is.
Op amp.
Op amp.
So, yeah, the negative term. Yeah. Did that make sense?
So you just completely ignore the 8.3 resistor?
I didn't ignore it, but when you write KCL, if I change the value of that resistor, does it change the current that's passing through that branch or not? Why not? There's a current source. Okay. Yeah. That's it. What else?
I mean, there's more op amps on that exam. You don't have to do it.
If you want, just ask.
Could you scroll up a little?
If I have done something, because I'm not
We're looking for
and remember, most of the time, okay, I'm saying most of the time, okay, then don't sue me for that. Most of the time, the output resistor, the RL here, is just useless, okay? So if you didn't use it, don't be surprised. Yes?
G13.
The same year? Okay, should I assume that you've memorized it or no? No? Okay. What's this voltage here?
Is it just
VN.
Is it because I positive 0?
Yes, always the current going into the terminals of the op amp is 0. So what is this voltage? VN. So this voltage is also VN, right? So I have something like this. Right? Now, it's a voltage division. So I can write V out multiplied by R divided by R plus 12.2 kilo ohm is equal to V in. That's voltage division. So V out over V in is equal to R plus 12.2 kilo ohm divided by R, which is 1 plus 12.2 kilo ohm divided by R. What is the name of the left-hand side? Gain, right? It's equal to 10. So R is equal to 12.2 kilo ohm divided by 9. Can you, what is it? Do you have the value? It should be 1.356. Yeah. You see, it's not the end of the world if you didn't memorize it, but if you had memorized it, do you remember what was the formula for this? This is a non-inverting amplifier. The formula is 1 plus R2 over R1. This is R2 and this is R1. Anything else? No? Okay.